In the previous session, we learned about what exactly is a chemical reaction. We understood that chemical reaction is a chemical change, and then we also seen certain observations that you would actually find when a chemical reaction is taking place. And we also discussed in the last session that in this session we would actually be discussing about how to represent a chemical reaction in a simplest form so that you get more information out of it. Understood? So representation of a chemical reaction in the simplest form is actually known as a chemical equation. So in this session, we will learn about chemical equations and their representations, and whatever the examples we have taken in the last session, we will try to write the simplified version of those chemical reactions that we have discussed in the last session. So before we go forward, the simplest reaction we have discussed in the previous session was we used a magnesium ribbon. What is it? We used a magnesium ribbon which was allowed to react with oxygen. And what was the product that we obtained? Magnesium oxide. Correct? So do you understand anything in the way I represented here? Right? It is much simpler than putting it in the form of a sentence. Correct? So if I write it in the form of a sentence, that I have to write it in such a way that the substance magnesium is allowed to react with oxygen to form magnesium oxide. That is the whole sentence that I have to represent with. But if you look at this thing that I have represented here, it says that something magnesium is reacting with oxygen. So I'm separating the substances that are reacting in a chemical reaction by a plus sign. And these two are combining to form a new substance, that is magnesium oxide. So here I am showing it by an arrow in which direction this chemical change is happening. So whereas the substances that are combining together to form that new substance were referred to as reactants. Whereas the new substance that is formed after reactants combine with one another is known as products. And the arrow representation gives us that in which direction the reaction is actually proceeding in. Do you understand? And this representation is known as word equation. What is this? Word equation. Okay, if you look at this, I have the data very clear and very crisp. So it is magnesium reacting with oxygen to form magnesium oxide. You understand? So this is one of the simplest representation of a chemical reaction, right? Now let's try to put it in a different way which gives even more better information than we actually written here. So in grade 9, have you studied about, writing a chemical formulae? Have you studied about it? Yes, we did study in grade 9 how to write a chemical formulae. But even then we will try to recap how did we do that, right? So here magnesium is an element. So we have learned to write the symbol of the elements. That is, magnesium is represented by the symbol Mg. Correct? Whereas oxygen is also an element, but in the nature it exists as what? O2. So this is a diatomic molecule. Correct? So now when I write it in the form of symbols, and the similar way as I add the plus sign, it also represents the same thing that is represented in the top. Correct? Now this magnesium is combining with this oxygen that is present in the atmosphere in the form of a molecule to give a substance that is known as magnesium oxide. So in grade 9 we learned that writing the formula of magnesium oxide, the first thing we do is figure out what is the ions present in this given particular compound. So there is, as per the rules, you always write the cation first followed by the anion. So that means that magnesium is the cation whereas this oxide is the anion. Correct? So we understood that there is a cation which is known as what? Magnesium, and the symbol of magnesium cation is Mg plus 2, whereas oxide anion is given by O minus 2. So this is the first step in writing the formulae, that is you represent the symbols of those ions. Now what is the charge of those ions? So this is plus 2 and this is minus 2. So this is the first step. So we figured out what is the charge of those ions and what are the symbols of those ions. This is the first step. And the second step would be what are the atoms present in the given ions. So here there is an Mg atom, here there is an oxygen atom. And what is the valency of these atoms? So if you look at the valency, in grade 9 we learned that valency is nothing but a whole number that is actually the charge on the ion which is taken as a positive value, as a whole number, not a positive value. So that is 2. Here oxygen has a valency of 2. And we also learned valency is defined as the combining capacity of magnesium with the other atom. So what exactly that means is magnesium has an electronic configuration of what? 2, 8, 2. So to attain stability, it combines with the other atom by either losing this 2 electrons or gaining 6 electrons. But losing is easy compared to gaining 6 electrons. Hence, magnesium combines with the other atom by losing 2 electrons. Hence, the valency is 2. You understand? So this is the second step. And the third step is cross multiply the symbol of cation with the valency of anion and the symbol of anion with the valency of cation. So you would get what? Mg2O2, and if you are representing this in the simplest form, you would get what? MgO. Understand? So now here the product formed is what? Magnesium oxide, which is represented by the symbol MgO. So did I represent this in even more simplest form? So now what is the use of this? Okay, before we go ahead, I want to ask you something. Okay, suppose in your classroom you have a strength of 30 students, and now today around 20 students are present. So this is your first period. So all of you are getting into your classroom of 30 students. So how many we said? 25 students are present. So now out of this 25 students that are present in the classroom, if I send all the 25 students out, how many students will go out? 25 students only will go out. So the number of students coming into the classroom and the number of students going out of the classroom will be same. Will I get more number of students going out of the classroom? No, na. If the 25 students are present, I cannot say that 26 students are going out because there are only 25 students. So similarly, if there is a chemical reaction like this happening, if the number of atoms that are getting into the chemical reaction should be same as the number of atoms that are coming out after the chemical reaction has taken place. Correct? So that means here magnesium, this is represented by 1 magnesium. There is a number which is present in front of magnesium. These are known as stoichiometric coefficients. What is it? Stoichiometric coefficients. So similarly, it says that 1 magnesium atom is reacting with 1 oxygen atom to form 1 MgO. as per this equation. But if you look at this equation, how many magnesiums are there on the reactant side? One magnesium. So one magnesium is entering into the reaction. So one magnesium is coming out after the reaction. Okay, so that makes sense. But if you look here in the oxygen molecule itself, you have two atoms of oxygen. So that means if two atoms of oxygen are getting into the reaction, then the same two oxygen should come out. But whereas you see here, only one oxygen has come out. So that means that the representation that I made is not exactly complete. Correct? So hence the equation which is not balanced on the reactant side and product side is known as skeletal equation. Understand? And then the skeletal equation gives you what is reacting with what and to form what. And as we have told, this is an incomplete equation. So there is more to the skeletal equation. That is nothing but a balanced chemical equation. So out of this skeletal equation, how do we get the balanced chemical equation? So balanced chemical equation will give you if the number of atoms participating on the reactant side must be equal to the number of atoms formed on the product side. So that will be ensured correct by balancing this chemical equation. Indirectly, this chemical equation is following a law. Can you guess what exactly is that law? So here, as we told, the number of atoms participating should be same as the number of atoms that are coming out. So this tells that each atom has its own mass, correct? So if magnesium has some mass, and similarly even after coming out it is staying as magnesium atom, and still this magnesium atom will have mass. Similarly, if this oxygen has some mass, it is coming out as in the form of oxide, but the atoms still exist as oxygen. Hence, the mass of the oxygen is not lost after the reaction also. So this tells us that the mass of the substance that are combining in a chemical reaction before is equal to the mass of the new substance that is formed in a chemical reaction. So there is no mass that is lost or gained in a chemical reaction. So the only thing that is happening in a chemical reaction is new substance is formed. How the new substance is formed is here this oxygen which is present in the form of molecule, that is two oxygens existing together, they break their bonds and interact with magnesium. So they rearrange those atoms to form a new substance which is called as magnesium oxide. You understand this? So this is what happens in a chemical reaction. So we will also look at few of the examples that we have taken in the previous session. So one such example was rust. So how did rust form? So we have discussed that iron, when it is exposed to air, so air contains what? Oxygen, and similarly moisture in the form of H2O. So this reacts to form a substance which you are calling it as what? Fe2O3 dot XH2O. This equation is known as a skeletal equation. The reason is the equation is not balanced. Here there is one ion, but there is two ions. So hence the equation is not balanced. So hence this equation is also a skeletal equation. So after balancing you get what? Balanced chemical equation. We will learn how to balance this skeletal equation in the next session. Understood? And before that, let's take one more example we have done in the previous session. We allowed zinc to expose to an acid, for example HCl. So here the reaction was they interacted with one another to form a new substance, that was ZnCl2 plus hydrogen gas was released, where we have seen evolution of a gas here. Correct? And now here we will look at one more reaction taking a different acid where zinc is allowed to react with sulfuric acid, which is represented by the symbol H2SO4. It will form ZnSO4 plus H2 gas. So in writing these symbols, zinc chloride, zinc sulfide, you can apply the rules in writing a chemical formulae. So you will get this as simple if you know what is the cation, what is the anion, what is the symbol of cation, what is the symbol of anion. So you will get the formula of this compounds. You understand? And these two equations are also skeletal equations because they are not balanced. Because if you look at here, there is in this molecule one HCl has one chloride, whereas here there is two chlorines. Whereas here you see there is, this looks like a balanced equation, correct? There is one zinc, two hydrogens, one sulfur, four oxygens. Sometimes writing the equation could actually lead to a complete balanced equation as we have seen here. You understand this? So this is a balanced chemical equation because it has the same number of atoms on the reactant side whereas on the product side. So this follows law of conservation of mass. Law of conservation of mass states that mass can neither be created nor destroyed. You understand this? So hence in a chemical reaction, no new mass is created or destroyed. Whereas that directly says that there are no new atoms that are formed or no atoms that are actually destroyed in a chemical reaction. You understood this? And we will discuss one more reaction which we did not discuss in the previous session. This reaction has a huge lot of significance in grade 11th also, where this particular same reaction is actually utilized to confirm the presence of lead ions in a solution. So do you know the formula of lead? Lead is given by Pb. Okay, and this lead ions, Pb plus 2 ions. So let's take a solution of lead nitrate. If you are talking about lead nitrate, it is given by the symbol PbNO3. And this lead nitrate, which is colorless solution. This is colorless solution. So this, when it is dissolved in solution, it will form lead ions and nitrate ions, that is NO3 minus ions. So to this, when I add a substance which is known as potassium iodide, do you know the change? Can you guess the change? You know, this will be a beautiful change. When you look at the substance, you know, it looks very colorful. You know, it will turn into a yellow PPT. That is yellow precipitate because of the formation of lead iodide, PbI2 plus KNO3. So this PbI2 is insoluble in water, which will be purely yellow in color. The reaction will look really nice if you are experiencing it in front of you happening. I'm sure you will do this reaction in your grade 11th. Okay, and I hope you understood what is a chemical reaction and what is a chemical change and how to represent a chemical reaction. And in representing, we have discussed in representing the chemical reaction in the form of a word equation, whereas we also seen representing the word equation in the simplest form in using this formulae of those substances that are reacting and forming the product. And then we discussed all the examples that we have taken up in the previous session in understanding a chemical change. Correct? So in the next session, we will learn about how to balance this chemical reactions. As we have seen, we ended up getting some skeletal equations. How do you balance them? We will learn about this in the next session. Okay? Thank you so much. I'll see you in the next session.